Today we will be talking about the inverses of logarithmic functions and exponential functions. In the previous lesson we had talked about how logarithmic and exponential functions are inverses of each other. So we're going to explore that idea shortly, but first I want to go back to converting expressions from exponent form to log form. Now, we're not solving for anything, we're not evaluating, we're just going from one form to the other. So we have 3 to the x equals 11. So it's going to be log with a base of 3 of 11 equals x. That is your logarithmic form. The next one, we have log with a base of 5 of y equals the exponent x minus 3. Now again, I'm not asking you to simplify your solve or anything. I just want to go from log form to exponent form. And it's okay that our exponent is this expression, x minus 3. That's allowed. It's not something that we have to worry about. We could even have log base 5 of x minus 1, which is what's going to happen over here. We have log base 6 of, well, this whole thing is my other number. Now, because that whole thing will be my other number, it's going to be x minus 1. So log base 6 of x minus 1, if I'm taking the log of x minus 1, it needs to have parentheses around it. Because if I don't have parentheses around it, this is saying take the log base 6 of x, and then after doing that, subtract 1. But we want the log base 6 of x minus 1. And then it's going to equal our exponent y plus 7. So that is your logarithmic form. So I want you to try these problems. I want you to convert this exponent form to log form, and when you're done, unpause it to see if we get the same answer. Alright, so these are the answers that you should have gotten. For B and C, you do need parentheses there because you're taking the log base 4 or log base 14 of that entire thing. So the reason behind this is I wanted you to experience and see that you can still do this if you don't have nice numbers. The other day, all our numbers were just whole integers or fractions or negative numbers, not variables. But the same process applies when we have variables. So remember, for inverses, we interchange x and y, and then get the logarithm or power alone if possible. So we want just the log or just the exponent on one side of the equation, and then after that we switch forms. So if we start with a log, we go to exponent form, but if we start with an exponent, we go to log form. So we're switching forms. And then finally get y by itself, and then replace that with the inverse of f of x, or the inverse of y. So here we have y equals log base 3 over 2 of x. So the log's already by itself because this x is attached to the log. Like, I wouldn't want people to start, dividing by x and canceling it out, because now you would just have log base 3 over 2, but of what? Your log needs a base and an of number. So this is already by itself, so we're going to switch our x and y. Whoops, y. The log's already by itself, so we have the base 3 over 2, so 3 over 2 raised to the x power equals y. I went from log form to exponent form. All right, y is by itself, so we are done. We don't have to do anything more. So then the inverse of y is 3 over 2, or 3 halves, raised to the x power. So this problem has a few things here to note. First is the ln, or natural log. So I know at some point that I'm going to have to go from log form to exponent form. Now, secondly, we cannot combine those two. This is the natural log, or the ln of x minus 4, so we have to do that first and then add 5. We can't do that negative 4 plus 5 and get 1. So our first step is going to be switching x and y, and when I do that, I'm going to switch the natural log to log base e. So I switched x and y, and I switched the natural log here to log base e. Now we need to get y by itself. Well, in order to do that, I have to get the log by itself. That minus 5 is not part of the log. So we have x minus 5 equals log base e of y minus 4. Now we have the log by itself. And again, you can't do anything with the stuff inside the log. It's all together. This is the log base e of y minus 4. We have two parts, the base of the log, which is e, and what we're taking the log base e of, which is y minus 4. So now I can go and have e raised to, well, this whole thing is on the opposite side of the word log. So my exponent is x minus 5. And that's going to equal the whole other stuff, y minus 4. All right, our last step, and I'm just going to recopy this over here. We have e to the x minus 5 equals y minus 4. Our last step, we need to get y by itself. So adding 4 to both sides. When we add 4 to both sides, that does not get added to the exponent. When we graphed exponential functions, we had an h value and we had a k value in some of these. Well, now you can clearly see our h would be 5 and our k would be positive 4. So that 4 does not get added to the exponent. Y is by itself, so the inverse of y is e to the x minus 5 plus 4. And that would be your inverse. Letter C, this is an exponential function, so we know we're going to convert it to log. So I'm going to switch x and y. X equals 7 raised to the 2y power. Now the base is already by itself. Like, we already have 7 alone, and it's being raised to the now 2y power. So now I'm going to switch this to log. Log base 7 of x is equal to the exponent, which is 2y. 2y. Y is not by itself, so we divide everything by 2. And when I do that, nothing really changes about the log. It's still going to be log base 7 of x, but now it's just going to be divided by 2. No big deal. And that equals y. So then our inverse is log base 7 of x divided by 2. So that's our inverse. All right, now the last one over here, we have exponent form, so we know we're going to convert it to log at some point. So we're going to switch x and y. X equals 4y minus 5 plus 6. The base is 4. This is not by itself yet. So we're going to subtract 6 from both sides. X minus 6 equals 4 to the y minus 5. Now that I have the base by itself, I can switch this to log form. So log base 4 of, this whole thing is my of part, my other number. X minus 6 is equal to the entire exponent, y minus 5. Then to get y by itself, we'll add 5 to both sides. And again, that 5 does not get added inside the log. So it's going to be log base 4 of x minus 6 and then plus 5, which makes our inverse log base 4 of x minus 6 plus 5. So the tricky part about these inverses is you have to be comfortable that your exponent or your other number isn't just a number or a letter, it's an expression. Like here, our other number is x minus 6. That's allowed, there's nothing wrong with that. So on the next page, before I have you try these last 4, if the original expression, if the original function is an exponential one, the inverse must have the word log in it. I can't tell you how many times over the years I would say, find the inverse of something like letter B here. It's an exponential function, so I need to see the word log in there somewhere, or the natural log. Now, if we started with the log, then that means my inverse should be an exponential. So I should not see the word log in the inverse, like letter A right here that I'm going to have you try in a moment. That is a log, so when you find the inverse, it should no longer have the word log in it. So I want you to pause the video and try these 4 problems, and then we're going to talk about them, and mostly I want to focus on letter C when you're done. Alright, so let's look at each one of these. Hopefully this one wasn't too bad. The x plus 1 was attached to the log, so that's why I did not subtract 1 from both sides before switching it to log form. So I had 4 to the x equals y plus 1, and when you subtract 1 from both sides, you get 4 to the x minus 1 equals y. So that would be our inverse right here. Now, letter B, I wanted to pay attention to how I wrote my final answer. So I switched our x and y's, and then the base was already by itself. 5 was our base. It's already alone. It has nothing attached to it. So I could go right into log form. So when I did that, I had log base 5 of x equals y minus 4. And when I add 4 to both sides, I get log base x, or log base 5 of x plus 4. Now that plus 4 was not attached to the log, because once I converted it to the log, this is my log right here. If I now add 4 to both sides, that does not change my log. My log is still log base 5 of x. So you would not put parentheses around the x plus 4. So this is log base 5 of x, then plus 4. That plus 4, again, does not count with the log. If it did, you would see parentheses around it. All right, like letter C here, again, a couple things I want to talk about. First, we had to switch x and y and then subtract 7 from both sides. Now, we had x minus 7 equals e to the y power. Once I switch it to the log form, this x minus 7 is what I'm taking the log of, so that needs to stay with my parentheses. Stay in parentheses with the log. Now, we haven't talked about this a lot at this point, but the log base e, remember, is the natural log. So you want to make that change from log base e to the natural log. And then lastly, the ugliest one, we had 2 log base 3 of x plus 5. Now that, after I switched x and y, I did subtract 5 from both sides because this 5 is not part of our log. Because our goal, after we switch x and y, our goal is to get the word log by itself. Again, that 5 is not attached to it. This 2, we're going to divide by. So that's why I subtracted this 5 after switching the x and y. Then I divided by 2 to get the log part by itself. Remember, This is what we're trying to get alone. And when I divide by 2, I finally get that by itself. Now I switch this to exponent form, and yeah, our exponent has a lot going on in it. That's okay though, it can stay there. So we have 3 to the x minus 5 power over 2. And that's okay. So again, the difficult part about this is that things don't look nice. And that's just the way finding inverses of exponentials and logs are. They're not always going to look nice. They're going to have variables all over the place or fractions. So just trust yourself in the process and you're going to do great. So thanks for watching. Make sure to like the video and subscribe.